Is up, everybody? Mr. Hissner here, and today we're going to continue doing segment proofs. Now, the segment proofs we're going to be doing today are not going to have the statements filled in for us. We're going to have to go through and fill in those statements on our own. And so what this means is that we're going to have a discussion and think about not only why the things are going to happen, but what's also going to happen, just given the figure. I'm going to be working with this figure today, and this figure is a pretty popular figure and pretty important figure. So we're told that AC is congruent to DF, so these whole segments are congruent, and then we're told that these pieces are congruent. And what we want to prove that AB is congruent to EF, right? So we want to prove that these two pieces are the same. That's what we want to prove. That's what we want to prove. We want to end with that. And of course, we're going to begin with AC is congruent to DF, and BC is congruent to DE, and this is, of course, given. So let me just have a quick discussion. If you notice here, we don't have a midpoint, so we're not going to be using a midpoint. We have segments, and we have segments, right? So what I'm going to do here is I'm thinking, well, I'm probably going to have to use segment addition to turn the segments into numbers. So I'm going to have to use segment addition to turn them into numbers. And so that means that I'm probably going to have to use that property of congruence. So this is the definition of congruence. I'm also probably going to have to use the segment addition, right? Because that's really what we have here. BC is equal to AC. We have DE plus EF is equal to DF. So we have segment addition. So I'm also thinking, like, maybe I can make a substitution somewhere and probably use the transitive property to wrap things up. So I'm going to go from numbers to like some addition. I'm going to make some substitutions. I'm going to do some transitive property, but I have to get back to segments, and so I'm probably going to use the definition of congruence twice. First, to change them from segments to numbers, use the numbers, then to change the numbers back to segments because I'm ending with segments. So that's actually what I'm going to do first. Let us do this first. So I'm going to take these and make them into numerical values by the definition of congruence. Then I'm going to state the segment addition. So I know that this is going to be true, that I can add the pieces to equal the whole things. DE plus EF. So this is segment addition for both of these properties. Okay, and now let's see if we can use the transitive property or maybe a substitution. Maybe a substitution. Well, look at this. Look at this. Look at this. Well, AC is the same as DF. So I'm going to make a substitution here. I'm going to say that AB plus BC is equal to DF by a substitution. I think that's too many, but whatever. By a substitution. Now, watch this. I'm going to have to bring this home with the transitive property. What I want to show you all is that we have DE plus EF is equal to DF, and we also have DF is equal to AB plus BC. Okay, and notice, watch this. If I just get rid of these DFs, because they're the same thing, and I just put DF here, I have A is equal to B is equal to C, so A is equal to C. And so we have DE plus EF is equal to AB plus BC, and that is how we use the transitive property. We're using it to link these things. So whenever I have one thing that is equal to two other things, I know that those two other things are equal to each other. And so I'm going to plug this back into here and use that transitive property. So here is my use of the transitive property. I'm going to do it like this just because it looks a little bit better. AB plus BC, that was equal to DF. Well, so was DE plus EF. Okay? And that is the transitive property. That is the transitive property. Transitive property of equality. Okay, so what am I going to do? Well, I want it to look like AB is congruent to EF. So how about I subtract a BC from both sides? Can I do that? BC, EF. B, C, D, E. Oh, you know what? I should do another substitution. I'm getting ahead of myself. Maybe I'm gonna have to do another. I'm gonna have to do a double sub. It's because I need this to be a BC, right? And I can make it into a BC by another substitution. So that's what I'm going to do actually, is I'm going to make this into a BC plus EF is equal to AB plus BC by another substitution. And now I'm going to subtract BC from both sides. So this will look like AB is equal to EF by the subtraction property of equality. I'm allowed to subtract two numbers from the both sides. And now how I can finish this up, yes, this will be AB. The segment is congruent to EF, the segment, because that is literally the definition of congruence. Fun proof. So what time am I at? I don't know. So let me just go back and recap. I knew, given this figure, I wasn't going to have the midpoint. There's only so many things that you can use, really, in a segment proof. There's only so many things you can use. Definition of congruence, segment addition. There wasn't a midpoint, so I can't use that, right? Then the definition of congruence, just this, I'm going to have to make a substitution. There's probably going to be a transitivity in there somewhere. I had to actually make a double substitution and then use the subtraction property. This one did get a little flaky at the end, but it is an elegant and pretty nice proof. So yeah, thanks for watching.